Hey everyone, welcome to the lecture for 3.4 on composition of functions. So our goal today is to be able to say, I can combine multiple functions through addition, subtraction, multiplication, division, and composition. I can combine these functions algebraically, graphically, and from a table. So we're going to start with combining functions using algebraic operations. So that's addition, subtraction, multiplication, and division. So we can see here in our definition that it's going to be just pointwise. So we're going to evaluate each function at a certain value, and then we're just going to add them together. So let's start with some algebraic examples. So in example 1, we're given two polynomials, f and g. And we are asked to compute the sum, the difference, the product, and the ratio for 3 given x values. So just in general, f of x plus g of x is going to be x squared plus 2x plus 6 plus x squared. And so I can actually combine like terms here because the parentheses aren't really doing anything for me. They're mostly just kind of highlighting or emphasizing which part comes from f and which part comes from g. So this is really just 2x squared plus 2x plus 6. And so, actually, how should I write this? So this is the same thing as writing f plus g of x, right? This is how we define it here. So if I have f plus g of 0, it just means I'm going to plug 0 into the function 2x squared plus 2x plus 6. So that's going to be 2 times 0 squared plus 2 by 0 plus 6. So that's going to give me 6. Now the other way I could have done it is I could have done it piecewise. I could have also said that f plus g of 0 is equal to f of 0 plus g of 0. And this is fine too. So f of 0 is 0 squared plus 2 times 0, right? This was the f part, f of 0. And then I also have 6 plus 0 squared. Right, and this was g of 0. But either way, I get the same outcome. So that's f plus g of 0. I could also compute f plus g of 2. Again, you can do it piecewise, f of 2 plus g of 2, but since we already kind of have it simplified over here, I'm just going to use the simplified version on the left. So this is 2 by 2 squared plus 2 by 2 plus 6. So that gives me 8 plus 4 plus 6, which is 18. And then lastly, I want to do f of g, f plus g of -1. So this is going to be 2 by -1 squared plus 2 by -1 plus 6. So that gives me 2 minus 2 plus 6. So I get 6 here. Again, you could have done that pointwise if you'd wanted to. So next we have to do the difference, the product, and then we'll move on to division, f over g. So let's look at what f minus g is going to be. So f minus g of x is f of x minus g of x. And so that gives me x squared plus 2x, right? That was f of x, minus the quantity g of x, 6 plus x squared. So now the parentheses are really going to play a role because I have to subtract the whole, the sum of 6 and x squared. So you have to make sure to be careful and distribute that subtraction symbol, that negative. So I've got x squared plus 2x minus 6 minus x squared, right? So a lot of people will make this mistake and they'll be like, oh, it's minus 6 plus x squared. No, you've got to distribute the negative onto the 6 and onto the x squared as well. So simplifying by combining like terms, I get 2x minus 6. So let's just work with 0 moving forward, since we it's the same method for any x value. Alrighty, so what I'm going to get is f minus g of 0 equals 2 by 0 minus 6, right? So I'm just using this simplified form that we got on the left, and I'm evaluating it at a point, so I just get negative 6. And we can see here that for f plus g and for f minus g, they're both polynomials. So the domain is just all real numbers. I'm not going to have any square root of a negative. I'm not going to have division by 0. None of these problems that I kind of have to be on the lookout for when determining domain of a function. So both of them, the domain is all real numbers. So next we're going to look at f times g. So f times g, sometimes just written as fg of x is equal to x squared plus 2x, that's f of x, and then I'm multiplying that by 6 plus x squared. So here we have to expand this. Probably FOIL would be easiest. So you should get, I'm just going to go first, which is 6x squared, outside, which is x to the 4th, inside giving me 12x, and last, which gives me 2x cubed. So I can't combine any like terms, but what is typical you'll see here is to write this in descending order of powers. So x to the 4th plus 2x cubed plus 6x squared plus 12x. And again, this is another polynomial. So our domain is negative infinity to infinity, right? We're not going to have any division by 0, no square root of negative numbers, no problems. So if I wanted to say compute f times g of 0, I'm just going to plug in 0. So that's 0 to the 4th plus 2 times 0 cubed plus 6 times 0 squared plus 12 times 0. And each one of these terms is 0, so the sum of all these zeros is 0. So next, the last thing I want to do is I want to compute f over g of x. And so this is just f of x, which was x squared plus 2x, over g of x, which is 6 plus x squared. And here's where we have to start being careful with our domain, because we want to make sure that we're not going to divide by 0. So for our domain, we just want to look at, is there a place where 6 plus x squared equals 0? And again, we're just considering real numbers here. So I'm going to go ahead and use the square root method. And so that I get x is plus or minus root 6i. So there are no real solutions that are going to make my denominator equal to 0. And so my domain is still all real numbers. So let's go ahead and compute f over g of 0. So this is just going to be 0 squared plus 2 by 0 over 6 plus 0 squared. And so that gives me 0 over 6, which is 0. All right, so the next example we have is a little bit trickier, because now instead of having two polynomials, we have two rational functions. So we're just going to do it for the single value x equals 3. And we have g being 1 over 6 minus x, and then we have f is 1 over x minus 4. So f plus g of x is equal to 1 over x minus 4 plus 1 over 6 minus x. We could find a common denominator and put these together, but I'm okay with not doing that. I just really am focused on first finding the domain. So we can just see straight off the bat that our problems are going to occur with division by 0. So we have to make sure that x cannot equal 4 and that x cannot equal 6, because either one of those is going to present a problem for us because it'll lead to division by 0. So for our domain, we want to go from negative infinity just up to 4. We want to jump over 4, go all the way up to 6, jump over 6, and then head on out into the sunset. So this is what our domain would look like here, right? So notice that when I go up to 4 and it's open, and then I put the union symbol, and then I start again open at 4, basically the number line looks like this. So if you have 4 and 6, then your number line, if you were to graph it, it's just these 3 segments here, right? So you're just saying, I'm cool with any single number that's, any value for x, except for 4 and 6. So this number line here in orange is equivalent to the interval notation right above it. All right, so let's go ahead and compute f plus g of 3. So that's going to give me 1 over 3 minus 4 plus 1 over 6 minus 3. One over 3 minus 4 is 1 over negative 1, and 1 over 6 minus 3 is 1 over 3. So I'm going to get negative 1 plus 1/3. So I could simplify that. If this was negative 3 over 3 plus 1 over 3, that would give me negative 2/3. All right, if I did f minus g of 3, right? So f minus g of x equals 1 over x minus 4 plus 1 over 6 minus x. Well, the domain is the same. We have the same issues here. So I'm just going to copy down what we had from before. And then I'm going to evaluate my function at 3. So I have 1 over 3 minus 4 minus 1 over 6 minus 3. So that's giving me 1 over negative 1 minus 1 over 3. So same thing again, negative 3 over 3 minus 1 over 3. And now I get negative 4/3. So for my next part, I'm going to do the product. So I'm going to have fg of x. And that's going to be 1 over x minus 4 times 1 over 6 minus x. And again, the same problem arises. I can't divide by 0. So I'm going to have 1 over x minus 4, 6 minus x, right? So the domain is still the same. I could simplify the denominator a bit. So if I have x minus 4 and 6 minus x, I could expand that. I'm going to do that here in some scratch work area. So I'm a big fan of using the square. So if I have x minus 4 and 6 minus x, that gives me 6x minus x squared minus 24 and 4x. So if I wanted to write this in a simplified form, I would write in my denominator negative x squared plus 10x minus 24. So now I want to evaluate this at 3. So I have f times g evaluated at 3. And I'm going to get 1 over. Now I could keep it at x minus 4 and 6 minus x. That's fine. Or I could use the negative x squared 10x 24. Let's do that. So I have negative 3 squared. So just to be extra clear, this is not saying negative 3 squared, right? That would be x squared for x equals negative 3. This is saying negative x squared. So it's negative, and then whatever your x is, you square it. So they're a bit different. So be careful there. Plus 10 times 3 minus 24. So it's going to be 1 over negative 3 squared. So negative, I'm just copying down the negative sign. 3 squared is 9. 10 by 3 is 30. And then I'm subtracting 24. So this is going to be 1 over negative 3. Or you could write negative 1/3. And then the last thing we want to do is we want to do f of x, or f over g of x. So I want to have f over g of x. So this is 1 over x minus 4 over 1 over 6 minus x. So I can flip the bottom. So you could do keep, change, flip if that works for you. Some people do the sandwich method where they say, oh, it's this and this. Whatever works for you for dividing by fractions. So I just like to multiply by the reciprocal, which is the same thing as keep, change, flip. So this is 1 over x minus 4 times 6 minus x over 1, which simplifies to 6 minus x over x minus 4. And now what we've done is we've created a different type of restriction on our domain. So now the only problem is that x can't equal 4. So if I write my domain out, I'm not worried about the 6 anymore because now it lives in the numerator. So I'm just going to have negative infinity to 4, pop over 4, and then head on out to positive infinity. So I'm going to evaluate now f over g of 3. And I'm going to get, so I'm using this here, my simplified form. I'm going to get 6 minus 3 over 3 minus 4, which gives me 3 over negative 1, which gives me negative 3. All right, so next we're going to work on some functions involving a radical. So to start, f plus g of x equals just f of x, which is 3x squared plus 2x. And I'm going to add to that g of x, which is the square root of x minus 5. And again, here the parentheses aren't doing anything for me, but just to emphasize the fact that the first two terms come from f, and then the last term with the radical comes from g. So there's really nothing to do as far as simplification because there are no like terms to combine. I want to look at the domain. So for the polynomial part, 3x squared plus 2x, there's no issue there. I can plug in whatever I want, any real number. But for x minus 5, this is telling me that x minus 5 has to be greater than or equal to 0, right? Because we need to plug in non-negatives into our radical. So then I go ahead and I solve that for x. So I see that x has to be greater than or equal to 5. So for our domain, you want to start at 5 and go out to infinity. So now I'm ready to evaluate f plus g of 6. So that's going to give me 3 by 6 squared plus 2 by 6 plus the square root of 6 minus 5. So I've got 36 by 3, which should give me 108, right? So 36 by 3, 90 and 18, yeah. And then I have 2 by 6, which is 12. And then I have the square root of 1. So this gives me 121. So next we'll do f minus g of x. So this is 3x squared plus 2x, that's f, minus g, which is root x minus 5. And we can see that the domain is the same because whether or not I am adding g or subtracting g, I still have the restrictions on what the radicand can be. So I still have 5 comma infinity. And then if I want to evaluate f minus g at 6, I'm going to get 3 by 6 squared plus 2 by 6 minus 6 minus 5. So that gives me 108 plus 12 minus 1. So now I'm at 119. All right, so the next two, I'm going to multiply right, and I don't have any change here as far as my domain restriction because I still have to make sure that the radicand is at least 5. So I still have that, and I'm just going to go ahead and evaluate at 6. So now I get 3 by 6 squared plus 2 by 6 times the square root of 6 minus 5. So that's giving me 108 plus 12 times the square root of 1. And so this is just 120 times 1, which is 120. F over g of x. So this is going to put 3x squared plus 2x is my numerator, and then my denominator is the square root of x minus 5. So we already know that x has to be greater than or equal to 5 just for g of x in general. But we also have to eliminate the possibility of division by 0. So when does that happen? So x minus 5 root equals 0 would be the same thing as x minus 5 equaling 0. So x equals 5. So we have to exclude this value as well. So we have a very similar domain, except in addition to being greater than or equal to 5, we're also not allowing it to be 5. So our domain just changes by one single value. So now I have the open interval 5 to infinity. So if I want to evaluate f over g of x when x is 3, I have f over g, sorry, when x is 6, I've got 3 by 6 squared plus 2 by 6 over the square root of 6 minus 5. So that's going to give me 108 plus 12 divided by the square root of 1. And this is just 120 over 1, which is 120. So in the next video, we're going to look at combining functions with arithmetic from a graph and also from a table.